For billions of years, the sun has been the silent architect of life on Earth. Every sunrise, every growing leaf, every breath we take is a gift powered by the unimaginable furnace burning at the center of our solar system. But even the greatest stars have an end, and in the deep future, far beyond human civilization, beyond every mountain and ocean, the sun will begin a transformation that will rewrite the fate of everything we know. This is the story of how a star ages, and how its final chapters will reshape the solar system in ways almost impossible to imagine. Right now, we live in what astronomers call the sun's main sequence phase. It is stable, predictable, and perfectly balanced, fusing hydrogen into helium in its core. This delicate process releases the light and heat that make Earth habitable. But deep inside the sun, something irreversible is slowly happening. The hydrogen is running out. In about 500 million years, this quiet shift begins to show its first signs. The sun's luminosity will increase by nearly 10%. A small number to us, but catastrophic for Earth. Higher brightness means higher temperatures, and the planet's climate will start moving into a runaway greenhouse effect, similar to what happened on Venus. Oceans will evaporate, clouds will disappear, the sky will turn hazy and dim with rising water vapor. Earth's atmosphere will become a trap for heat, pushing the temperature toward levels no life could survive. But this is only the beginning. As the sun grows brighter, it expands slightly. Planet Earth, once a blue jewel floating in cosmic darkness, now will be scorched by a sun that appears larger and hotter than ever before in human history. In around 1 billion years, Earth oceans will be completely gone, boiled off into space. Weather, as we know it, ceases to exist. Wind, rain, seasons, everything becomes a memory, etched into the planet's ancient rocks. The continents crack under the extreme heat, and Earth transforms into a dry, barren wasteland. But the sun has much bigger changes ahead. These early transformations are just the opening act of a cosmic drama billions of years in the making. The sun becomes a red giant. When the sun finally runs out of hydrogen in its core, gravity pushes inward while the outer layers expand outward. The sun will inflate into a red giant, growing enormous, so large that Mercury and Venus will be swallowed completely. Earth's fate in this stage is one of the greatest astronomical debates. Some scientists believe the sun will engulf Earth. Others propose that Earth might escape by drifting outward due to mass loss. But even if the planet survives physically, its surface will be a molten hellscape glowing under a monstrous red star. The sun will become hundreds of times bigger and thousands of times brighter. Mountains will melt. Atmospheres will burn away. Any trace of human civilization, cities, monuments, languages, history will be erased forever. This is the era where the inner solar system dies. As the sun swells and intensifies, something unexpected happens. The frozen worlds beyond Mars begin to thaw. Jupiter's icy moons, Europa, Ganymede, Callisto, may transform into warm oceanic worlds for a short time, becoming more Earth-like than Earth itself. Saturn's moon Titan, with its thick atmosphere, could briefly host liquid water instead of methane. Even Pluto, billions of kilometers away, may grow a thin atmosphere as frozen nitrogen melts. Planets that were once frozen in eternal night will bask in a warm red glow. But this golden age for the outer solar system won't last.
The red giant sun burns quickly, burning violently, and dying fast. The sun sheds its skin. Near the end of its red giant phase, the sun becomes unstable. Solar winds intensify. Outer layers begin to blow away into space. The solar system fills with glowing gas, blue, green, purple, forming a planetary nebula, a stunning cosmic cloud that will expand for thousands of years. This nebula is the sun's final breath. At the center of this beautiful cloud will remain the exposed core of the sun, small, hot, and fading. It will become a white dwarf, a stellar ghost, about the size of Earth, but with half the sun's mass, glowing like a dying ember in the cosmic night. The final era. At the end, the sun will no longer shine with nuclear fire. It will no longer warm planets or grow life. It will simply cool, slowly dimming over trillions of years until it becomes a cold black dwarf, invisible against the backdrop of the universe. A star that lived for nearly 10 billion years will fade into silence. As the sun collapses into its white dwarf form, the solar system enters its final chapter. The bright yellow star that once nurtured life is now a tiny, brilliant point of light, no larger than Earth, but with a density so extreme that a single teaspoon of its matter would weigh tons. The nebula around it glows faintly, expanding slowly into the void, but eventually even that beauty fades, leaving behind a cold system filled with dead planets, drifting stones, and ice-covered moons. This is the era after the sun, a cosmic graveyard where time itself seems to move differently. The fate of the remaining planets. With the sun now a white dwarf, its gravitational pull changes. The inner planets, Mercury and Venus, are long gone, vaporized during the red giant phase. Earth may have been swallowed or blasted by radiation, but even if its rocky core survived, it now circles the sun like a burnt, lifeless relic. Mars, once a red desert with hints of ancient rivers, becomes even colder. With nearly no sunlight left to warm it, its atmosphere freezes out entirely. The almost majestic Olympus Mons stands frozen in the dark, a silent monument to a world that never had the chance to evolve life the way Earth did. Farther out, Jupiter and Saturn remain massive, swirling gas giants, but their beauty disappears. Without sunlight, their colorful bands turn dull and shadowed. Their moons freeze solid once again. The almost majestic Olympus Mons stands frozen in the dark, a silent monument to a world that never had the chance to evolve life the way Earth did. Uranus and Neptune, already cold and distant, sink into even deeper darkness. Their atmospheres thicken, collapse, and settle. The entire system becomes a place where nothing grows, nothing moves, and nothing changes for billions of years. A universe that moves on. While the solar system slows into eternal stillness, the universe outside it continues its grand dance. New stars ignite in distant nebulae, new worlds form in swirling disks of cosmic dust, new galaxies collide and merge in spectacular explosions of light. But our sun, once a vibrant yellow star, is now a tiny, dim white dwarf, watching from afar as creation continues without it. The stars that were once its neighbors slowly drift away over millions of years. Constellations dissolve. The patterns humans once recognized in the sky, Orion, the Big Dipper, Scorpio, stretch out and fade beyond recognition. Even the Milky Way itself will eventually transform, merging with the Andromeda Galaxy in a slow cosmic collision. In all of this, the sun remains quiet, sinking deeper into the cosmic background. White dwarfs do not shine by fusion. They shine only by leftover heat, and like all hot objects exposed to the cold of space, they cool slowly and endlessly. After billions of years, the sun's white dwarf core dims until it resembles a faint blue ember. Over time, even that glow will fade to black. This final transformation gives birth to the rarest kind of stellar remnant in the universe, a black dwarf. Cold, dark, silent, invisible. A corpse of a star that once illuminated entire worlds. Could anything survive this future? When we imagine the far future, we wonder whether life, any life, could remain. Could humans leave Earth and settle